क्लास में, और आज हम बात करेंगे फ्रिंज विड्थ के बारे में। व्हाट इज़ फ्रिंज विड्थ? प्रीवियस क्लास में हमने किस बारे में बात करी थी? हमने बात करी थी यंग्स के डबल स्लिट एक्सपेरिमेंट के बारे में, और यंग्स का डबल स्लिट एक्सपेरिमेंट था इंटरफेरेंस के बारे में। What is the interference? And interference is the phenomena of light when the two coherent wavefront superimposed each other, then we get the of the light. All right, now I share the link to all of you guys. Please join the class. All right. I send the links to all of you. Please join the class. And let's start with the fringe width. In the previous topic, we already discussed about the interference pattern of the light. When the light, when the plane wavefront is passes through the two slits, and these waves are superimposed each other on a screen, then we get the bright and the dark fringes, and the dark fringes. This is known as इंटरफेरेंस। और ये जो फ्रिंजेस हैं, इनकी जो हम क्या बात करेंगे, इनकी विड्थ के बारे में बात करेंगे कि ये फ्रिंज है, इनकी विड्थ कितनी होगी। ऑलराइट, तो चलिए इसको कैसे कैलकुलेट करें। तो यहाँ वही वाला फिगर फिर से ठीक तरह से ड्रॉ कर लेते हैं हम एक बार। तो हम सबसे पहले बनाएंगे टू स्लिट्स, 1 and 2. What? 1, 2. All right, so these are the two slits. Make them in the proper gap. All right, now draw a screen. Now this is the screen. All right, again this is the center, this is the point A, this is point B. Basically these are these points are working as a fresh source of the light. All right, now the D is the distance between them. All right, and just name these points also. Let's see, E, F. All right, and there is another point P where we just want to know the width of the fringe. All right, so the both light waves are incident on this point. All right, just like that. This is the point P. Now let us consider the distance of this point from the center, that is x. All right, and the distance between the slits and the screen is capital D. What is our topic name? That is fringe width. So let's this right here, fringe width. All right, now so जो भी हमने यहाँ पर बनाया है फिगर में, इस फिगर में, इसको हम यहाँ पर एज इट इज़ लिख देंगे। मैं नहीं लिख रहा हूँ, आप लोग लिख लेना। कैसे लिखोगे? लेट अस सपोज दैट देयर आर two slits A and B and the light crosses over these slits at work and the point on A and B as works as a fresh source of light, so they create their own क्या बोलते हैं उसको, मैं वर्ड भूलने लग गया हूँ, मेरा दिमाग ख़राब हो चुका है। सही है, बहुत ही ज़्यादा। अभी भी याद नहीं आ रहा है। डिस्प्लेसमेंट्स, सही है, डिस्प्लेसमेंट। ठीक है, मुझे बार बार डाइवर्स याद आ रहा था, बार बार डाइवर्स, डिस्प्लेसमेंट्स। सो these two sources are creates their own displacements, so these displacements superimpose each other, so these are the different wave. All right, but as we know that these are the coherent source, so their wavelength, frequency and the phase are remain constant all the time. All right, so you have to write the exact same things that you draw in the figure right here. I'll start the derivation directly. All right, so let us consider a point P. Consider a point P at a distance x from C. What is C? C is the center fringe. Now the path difference between two waves arriving at point P. ठीक है, तो path difference जो है, path difference between two wave arriving point P. What is the path difference? That is the path of this wave start from point B is the BP and the path of this A is AP. Now we know that the light that arriving from the point B, it must be travel more than the light travel from the point A. So what is the distance that B travel more? That is BP minus BA. Sorry, not BA, that is AP. All right, AP. Let us suppose that the two objects at the same time start to travel from point A to P and from B to P. So the object start from B, that has to be travel more than the object from the A. What is the more distance? That is, if we draw a line perpendicular on this, this is the uh, this is the distance that the point on B has to be travel more. All right, now what is the distance? That is BP minus AP. So we have to find the path difference. All right, so we know that AB is equal to EF. All right, now AP is equal to EF is equal to D. These both have the same distance, the D, and AE is equal to BF is equal to capital D, basically the distance between the slits and the screen. All right, now what is PE? PE, then PE is equal to uh, d by 2. Basically this distance is the d by 2 and this is x, so we can write it x minus d by 2. So x minus d by 2. All right, now pf, what is the pf? pf is equal to x plus d by 2. All right, and why we are writing all these distances? So we have to calculate the path difference between both of the two, and we have to calculate the value of VP and AP. So here we can see that we have two right angle triangle, that is APE and BPF. All right, in these triangle, if we know the perpendicular and the base, and we know the value of base in both of the triangle, that is D, and the only we have to find that is perpendicular, and if we know the two sides of a right angle triangle, then we can calculate the third one. All right, so in these triangle we have to find the value of AP and BP. So just let it write down that AP, what is AP? So we can write the AP is equal to, according to Pythagoras theorem, AP square is equal to PE square. All right, PE square plus AE square. All right, this is the Pythagoras theorem, and we know we have to calculate the value of AP. So we can write that AP is equal to PE square plus AE square power 1 by 2, or we can say that it will cover the root. All right, so let's put out the value same as AP and same as the BP. So write it in this actual manner. We can write that here we have two triangle, here we have two right angle triangle, right angle triangle, right angle triangle, that is APE, triangle APE, and triangle BPF. All right, so we have to calculate the value of BP, that is BF plus PF square and 1 by 2. All right, so we have to put the value of BF and PF. The value of BF is D, this value. All right, so we can write it D square plus what is the value of PF, that is x plus D by 2 square the power of 1 by 2, and we can write it that D, put the D square is the common, so that is D 1 plus x plus D by 2 square upon D square. All right, and we can write it 1 by 2. All right, and applying binomial theorem, yeah, we can write it expanding according to the binomial theorem. Expanding according to the binomial theorem. ठीक है, we know that BP is equal to D 1 plus 1 by 2 x plus D by 2 square upon D square. All right, so we just assume this is as equation 1. All right, and now again we have to calculate the value of AP, so we take the triangle APE. All right, the triangle APE. So AP is equal to AE square plus PE square, and all the power have 1 by 2. Same, we have to put the value that d square plus, now this become x minus d by 2 square 1 by 2. Now same, take the d out from the section, that 1 plus x minus d by 2 whole square over d square, that has the power of 1 by 2. Now this term has to be expanded by binomial theorem, and we write it expanding binomially. ठीक है, binomially. So we get BP is equal to D 1 plus 1 by 2, 1 plus 1 by 2 x minus d by 2 whole square upon d square. All right, and we just assume this as equation 2. Now how to find the path difference? We know the BP minus AP. Now put the value of BP and AP. So the path difference is equal to BP minus AP. So let's write down the value of BP, that is D 1 plus 1 by 2 x minus d by 2 square over d square minus D 1 plus 1 by 2, all right, x plus d by 2 square over d square. All right, now take the d as a common, so the term become 1 plus 1 by 2 x minus d by 2 square over d square minus 1 minus 1 by 2 x plus d by 2 square over d square. And as we know that 1 plus and 1 minus will cancel each other, and we have 1 by 2 as a common now, then become d by 2, and d square is also common, so 2d square, and inside it become like x minus d by 2 square minus x plus d by 2 square. All right, and this is path difference BP minus AP, and when we solve this term, this become 1 upon 2d, and in inside only 4 into d by 2 is remain, and this is 2 से 2 ये cancel हो जाएगा, and then what we get, that is xd over d. All right, so we get the path difference of xd over d. This is the path difference. Okay, what is xd over d? And we know for the bright fringe, for the bright fringes, this path difference must be equal to n lambda, as we discussed in the previous section, that for bright fringe the value of distance, that is n lambda, so the n lambda must be equal to xd over d. If this is so, then we get the bright fringes. So what is the value of x? That is n lambda d over d. All right, so where n is equal to 0, 1, 2, 3 and so on. See, four bright fringes. All right. Now same as for the dark fringes, four dark fringes. Uh, we have the value of that the path difference xd over d must be equal to 2n minus 1 lambda by 2. The value of the x is become 2n minus 1 lambda d over 2d. Okay, and this is the required value of so this is the distance या width. ठीक है, this is the width for dark fringes. All right. Now if we compare in the both of the two, then we get the dark interference fringes are situated in between bright interference fringes and vice versa. All right, so this is the basics. All right, so this is the derivation for the fringe width. All right, now we have to calculate the fringe shift. And what is the phenomena of fringe shift? If we put a glass slab between the wave of the light, then the value of the fringes means where we get the dark and the bright fringe is shift from its place. All right, this is known as fringe shift. So if a transparent sheet of refractive index mu of thickness t is placed between one of the path of the interference wave, the optical path length of this wave will become change, and we get the shift between the original and apparent uh, position of the fringes. All right, so this phenomena is known as fringe shift. Let's write down here, that is fringe shift. What is fringe shift? Now when we introduce here we can say placed introduced a a glass slab of refractive index mu. All right, and thickness t between the path of one of the wave then optical path length, the optical path length of wave has changed, and this also changed the position of fringes. This is known as fringe shift. All right, this is known as fringe shift. Now just take out the value of this fringe shift. So we just assume that the refractive index, refracting in refractive index of that slab is mu, and its thickness is t. So the shift we get, that is the path of wave become mu t. All right, instead of t. So the difference we get, that is mu t minus t, or we can write it mu minus 1 t. All right, so if present position of the particular fringes, if present position of particular fringe is y is equal to d over d delta x. All right, what is the delta x? The new fringe width. All right, so the new position of the same fringe will be, so new position of same fringe is y dash, that is d over d mu minus 1, sorry, delta x plus mu minus 1 t. That will become the new position of that fringe. All right, now lateral shift in fringe is y naught is equal to y dash minus y dash minus y. All right, so put the value here, that is d over d delta x plus mu minus 1 t minus d over small d delta x, and then we have to calculate this. That is, then we got d over d delta x plus d over d mu minus 1 t minus d over d delta x, and these terms will cancel each other, and we get the d over d mu minus 1 t. All right, so as we know that beta is equal to lambda d over d, that is why d over d is equal to beta upon lambda. So we can write it here, beta over lambda mu minus 1 t. All right, so this is the fringe shift. What is the beta? Beta is basically the separation between the centers of the fringe. All right, so this is the fringe shift basically. No. Right, so if you find this video great, then like the video and share the video and subscribe the channel. All right. Thank you.